In this video, what I want to do is spend the entire time talking about something very important to all software languages, not just Python, and that is control structures. We talked about variables in the last video. We talked about functions and methods, and we did some things, but we didn't actually get to the point where we could write any useful code. So that's what we're going to do in this video. We're going to talk about how to control a lot of the functionality that we want our application to actually perform. And the first place that we're going to actually start is going to be with comparison operators. Now, I've already introduced this somewhat. So let's go into Visual Studio Code, or maybe we'll just use the command prompt. And we'll look at some of these comparison operators. I've opened up my command prompt, which you can also do if you're running this on a Mac. And I've also started Python in my command prompt, and you can see the cursor is actually flashing. So when we talk about a comparison operator, this idea again of the left side and the right side comes into play. So suppose I want to say is 5 greater than 3. And if I hit enter, you can see that this evaluates to 2. I'm comparing the right side and the left side, and I want a result. Now, another comparison operator that I can do is the, let's say 5 is greater than or equal to 3. Sorry, not 5, 3. And this also evaluates to true because the condition in the middle between the two numbers is really what we're using as our comparison operator. So you have to understand that the numbers that you see, 5 and 3, those are referred to as operators. Okay. And 5 is greater than 3, and that's why it evaluates. So the question is 5 greater than or equal to 3? But only one of the two is correct, which is true. 5 is in fact greater than 3, and that's why we're getting the true. Remember, this is all based off of math, okay? Now, is 3 less than 5? And I write this the other way around. And what do you think the answer is? True. 3 is less than 5. Okay, let's do another one. Let's say 3 is less than or equal to 5. And again, that's true. Okay, let's try this one. And I mentioned this in the last video. And we're going to say is 5 equal to 5. And this is a special case. And this is what we talked about so much in the last video when we talked about variables. This is now a comparison. Is the right side identical to the left side? And that's what this really means. This is not the same as this, 5 assigned to 5. Because if I type this in, I'm getting this syntax error. Let's look at another scenario. Suppose I want 5 is equal to the string of 5. As you probably already guessed, that is going to evaluate to false. And it's not only just the number, it's also the data type that it's looking for. On the right-hand side, we have a string of the character 5. On the left side, we actually have a number. So clearly we're going to evaluate to a false. So how do you suppose if I took the expression right above this one that evaluated to false, how could I get this almost identical line of code to evaluate to true? The answer is going to be through something called the not operator. And what this means is it is not equal to 5. Okay, and it's an exclamation mark, but it is in programming, most programming languages that I've ever seen, it is referred to as the not operator. So what this means is not equal to 5. And if I hit enter, you can see that this in fact evaluates to true. Now here's an example that's a little bit tricky. And we're going to compare two strings. And if I want to say ball, is this greater than an apple? And what do you think it is? And I'm going to let you look at it and think about it for a second. The reason it's evaluating to true is because ball, B, comes after A in apple. So technically the way strings are operating, a ball is greater because it comes after A. So if you look at alphabetical order, this is what it's evaluating to. The B comes after the A, and therefore it's considered to be greater. Now remember, I've said in the past that Python is case sensitive. So if I were to say ball is equal to ball, what do you suppose this answer would be? And it's false. It is because Python is case sensitive. They have to be identical in order to use that equal sign and produce a true. Okay, so this is why we refer to these as a comparison operator. I'm comparing everything about the right-hand side with everything about the left-hand side. In order to get a true, they must be identical, just like identical twins have identical DNA. Okay, and that's really why we talk about these as being a comparison operator. We are comparing left and right. But there's another reason why these two are not identical, and that's because they're identified in different tables as being very different. And you can see right here that capital B and lowercase b, their characters are actually different. While they may have very similar binary, they're not in fact the same, right? And so the different coding systems that we use to identify variables in memory, they're two different things. So when we look at this comparison operator, you can see here that capital B actually represents 66, lowercase b represents 98. So if I go back to my command prompt and I look at this, I can actually call a function and find out what those values are. And what I can call is this. I can say this ord b. Okay, and when I run this, you see that capital B's value is actually 66. Now, when I do the same thing with lowercase b, you can see that it represents 98. So that's why when we look at this ball equals ball in the different cases, we don't get the same answer. We don't get the same value because we know that 66 is not equal to 98. And that's why it evaluates to false. Now let's move on and look at conditional statements now that we understand comparison operators. In programming, our software applications are constantly being asked to evaluate the user's input. And you've done this yourself before. And based on your input as a user, your software application is now forced into making some sort of a decision. And so this is where we start to really consider conditional statements. Okay, but the real important thing is here, when we're talking about conditions, we need to evaluate the condition under which we need to evaluate what the user is doing. And when we do that, the importance really becomes on that condition itself. That's what allows our software to appear to make a decision based on the user's input. And so let's go over to Visual Studio and we can look at our very first conditional statement. And this is really going to be, we're going to talk about the if statement. Suppose I have a variable and I'm going to call it age, and I'm going to assign my age to be 20. Okay, so this is now where we can start playing with our decisions or give the appearance that our software can make a decision. Now, keep in mind as we do this, we're going to create our if statement. So if I'm going to say that my if age is greater than, let's say, 18, this is the first time that our conditional statement is going to be evaluated to true. Okay, so let me give you one little tip too. At the end of 18, you should actually type in the colon, and I'll tell you why. When I press the enter, you can see that it actually does an indentation. And this is for formatting. This is helping your compiler, but it is also making it more human readable in terms of the cleanliness of your code. Okay? So now what we can do once we've satisfied that that condition is true, we can now, let's say, as an example, print out a string, and this message can be, you are too young to drink. And that's drink alcohol. In Canada, anyway. Okay, so this is an actual true statement. So let's go ahead and I'm going to save that and I'm going to run that. Okay, took a little bit of time, but you can see right here, it evaluated the situation from the top down. And we know that age is less than 20 here in this particular condition. So the statement gets printed out to the screen. Okay, let's try something else. Let's try this. I'm gonna copy this and I'm gonna go to the next line and I'm gonna say, it is nice to be young. Okay, and let's run this one again. And now you can see that the same thing happens here. Okay, so just so you know that when you indent in this way, you see this bar is forming just under the I in the if statement. This means that this entire block of code is going to be executed because it relates to this if conditional statement. And that is the reason also behind the indentation. So let's say I want to take out that. And I'm going to say print, and in here, I'm just going to say thank you. Okay, now let's take a look and see what happens. Again, this one also printed out to the console. But this thank you, this condition, is not contingent on the evaluation of this conditional statement. So suppose I change this to 15, and then I run this again. And what you can see is because of the indentation that happened with this if statement, this conditional statement, 15 is actually less than 18. So therefore this condition evaluates to false. So what it did is it actually bypassed the first two print statements. And you can see right here, when I highlight it, there's 4 little dots. That's to indicate that that is what the indentation is according to PEP 8. And what it's done is it behaved like a typical compiler. It went from the top down, it hit line 1, and then it went to line 2. It was asked to evaluate a condition. It did so. And in this particular case, it revealed that this statement here is false. Therefore, it stayed out of this block of code and it moves right on to this next one in line. Okay, so it's as if though this block of code doesn't even exist according to the compiler. What I'd like to do now is go and change these values. I'll keep this to 15 and I'm going to change this to 30. You are old enough to drink. Okay. And I'm going to keep this one because it is nice to be young at 30 years old. I enjoyed it when I was 30. But now let's say we have another condition that we want to evaluate, but we want it to be sort of evaluating age each time. Now, rather than writing if with a condition multiple different times, what I can do is something called an elif, and that stands for else if. So we can say if, and then there's another condition, we say else if the other condition. So we can say age is greater than 20. And again, don't forget the colon. Now we can now go ahead and type out another message. So print, and this is a string, don't forget. It is very nice. And finally, I have one more condition that maybe I want to evaluate to, and it is this keyword else. So if the previous two conditions are not met or not evaluated to true, well, then I can end off with an else. And kind of the rule of thumb is you always try to balance it out. You start with an if, and you try to always end it with an else condition. And if you have more than those two if and else conditions, then in the middle, this is where we typically are going to put the condition elif, okay? But here's the special thing about this final else. If the previous two conditions evaluate to false, that automatically means that my final else condition is the one that evaluates to true. So I don't actually have to put in a condition. I can just put in the colon. And so what I'm going to do here is I'm going to print out another message saying, it is still great to be me. Okay, let's go ahead and save that. So take a moment and think about it and look at what is happening. I've got an age of 15, and the first condition I'm saying is my age greater than 30. So no, it isn't. Is my age greater than 20? And the answer is no. Therefore, it must default to this else condition. And it should write out that it is still great to be me. Thank you. So let's go ahead and run this. And as you can see, this is what we get. It is still great to be me. Thank you. Now, let's go ahead and change this to 35. And let's see what we get for 35. And I'll save that, and I'm going to run it. And my expectation is that I meet the first two conditions. You are old enough to drink. It is nice to be young. Thank you. Now let's run this one more time. Let's say we are 25. Okay. And I'm going to save that and run that again. It is very nice. Thank you. Okay, so I hope that that actually gives you a good sense of how we do this conditional statement. How do we evaluate what a user is going to put in? And keep something in mind. It doesn't always mean that the evaluation is going to be based on a user's input. It actually could come from another machine or another device or another location. It doesn't always just mean that the user is going to type something in, okay? So there are many different situations where we are going to use these conditional statements throughout all of our careers as programmers. We've done some really interesting things here with the conditional statements, but let's go ahead and make a couple of changes. I'll leave it at 25, and I'm going to say if age is greater than or equal to 18, we're going to talk about maybe post-secondary education enrollment. So eligible. So if you're eligible, it's because you're greater than or equal to the age of 18. And since I'm right now only going to use two conditions, I can go ahead and just get rid of this right here. And the next one is going to say not eligible. And I can go ahead and I'll just get rid of this print statement right here. So I'm going to go ahead and save that. Now, if I go ahead and run that just to test it out, you can see I don't have any syntax errors, and I'm eligible because my age is over the age of 18. So I'm good. And what if my age is 17? Let's just test that out. Okay. And run that as well. And now it says not eligible. So this is working exactly how we want. Now notice here of the two conditions, I did just go from if to else. But let me go ahead and show you something that is a little bit more clean and really useful to use. It's really the same way of doing this, but in fewer lines of code. And to do this, we're going to use something called the ternary operator. Okay, so this again is just a really sort of shorthand, faster, better way of doing the same thing that we've just previously been doing. So back in Visual Studio, one thing I want to do is I want to take out this print function, and I'm going to actually set it to a variable instead. That's something kind of new in terms of what we've done previously. So message is equal to eligible. And of course, eligible is still going to be a string, and I would prefer to change that to a capital E. And I'm going to go ahead and do the exact same thing right here in this block. And what we're doing here is instead of printing out two different messages, what we're doing is we are assigning a message in a string over to a variable. Now we're using the assignment operator again. So we've combined our comparison statements or comparison operators in our conditional statements, and now we're doing assignment operations again. And naturally, if we want to have an output to this, the next thing we have to actually do is print the message that we want. And this is nothing new from what we've been doing in the past anyway. And I'm saving that. And just to make sure that you all believe me, I'm going to go ahead and print this off. And you can see I'm 17, I'm less than 18 years old, and the message that was output was not eligible. So we know that that actually works. Let's clean this up a little bit and give me a little bit of room down here. And I can do one more thing after I indent this. With one line of code, I can actually do everything from lines 2 to 5. And the way I'm going to do this is I'm going to rewrite my message. And I'm going to write message is going to be equal to eligible. And of course, that's a string. If age is less than or equal to 18, else not eligible. And that's all I need to do. So naturally, I don't need to have these lines of code. I can get rid of those. So now what I want to do is just save it and run this code. And let's look at the output. So again, we're not eligible. But if I change this to 18, we're going to look at the output again. It's eligible. And of course, if I just put 25, I should get eligible again. Okay, good. So what I've done is I've eliminated a couple of lines of code and I put it all into one code. Now, I've shown you this method because it is less code, less lines of code. However, my personal opinion, it's not as easily followed. It's not as easily human readable in my opinion. But I do want to show you the two methods for doing this. You can do it either way, whatever you're more comfortable with. I actually prefer it in the method that I showed you before the ternary operator, but I do feel it's responsible that I explain it to you and you understand what it is. In Python, we have something called logical operators, and we have 3 of them, and they are and, or, and not. And so we can use these logical operators for various programming functionality that's a little more complicated than just your average if or elif or else. So let's go to Visual Studio Code and have a look at these. Let's look at two variables, and we're going to say high grades, and we're going to set that to true. And the next thing we're going to do is we're going to say volunteers, and we're going to set that to true. And let's say that this is going to be for a student that wants to get into a really good university. Okay, so the two conditions that we're going to say is, let's say they have high grades and they volunteer in their community. And so we're going to allow them into our university. So keep in mind, these two variables are Booleans. Okay, they have already got their data types and they are set to be a Boolean, both of these. Okay, so let's look at this here, and we're going to say if high grade and volunteers, then what are we going to say? We're going to put our colon in there. Don't forget the colon in this case. It's very similar because we're using if statement, so we're going to put in a colon. So we're going to say print, and in here we will type eligible. Okay. So what does this look like when we run it? And you can see here that this person is eligible. Now, I want to point out, you may be familiar with the and through different software that you've done before. And it would typically look like this. And it would be two ampersand signs. But in Python, we don't accept that. So we actually literally type out the word and. So what do we have to do to get this to be not eligible? Now, what we can do is go to the else. And don't forget our colon, and do another print statement. And this is where it's going to say not eligible. And under what circumstance would this actually be true? Because if you look on line 1 and 2, both of these are true. So therefore line 4. So what I would have to do is actually change one of these to false. And that is how we're going to get to the else statement. So if I go ahead and I save that, you can see now that this person is not eligible because they don't have high grades. So the takeaway there is that if both conditions are true, then this whole entire line 4 will evaluate to true as well. But if one or the other is false, then it's going to bounce out of this line or bypass line 4 and go into the next true line. And, you know, we've already just determined that if it is not accepting this first line as a condition of true, then automatically it just moves down to the next else line and executes the code in that block. So what if one of those conditions is false, the other is true? But in this line of code, if we say that either of those or one of the two conditions is at least true, then we can make this line actually work. And the way we can do that is if we say or. Okay, so in this language, we say if high grades or volunteers, one or the other is what it's saying, then print out this line. And so let's go ahead and save that and run that as well. And you can see that it is eligible. So the condition here is that they volunteer, but even though their grades are kind of terrible, maybe they can still get in. Maybe their grades are borderline. I don't know. The last one that we need to look at is actually the not operator. So I'm going to create this variable, student, And we are going to set the student to true. So the question is this person a student? And so what I can do is modify this line of code here. And I'm just temporarily going to get rid of this. And I'm going to say, if not a student, obviously I spelled it wrong, but if not student, then print out this line of code. Okay. And you look at this logic right now and you tell me what the output is actually going to be. So what we're saying is student, and let's get rid of that R because it's going to bother me. It shouldn't say student, but it does. So if the student is true, but then we say if you're not a student, then what's the resulting output going to be? So this is why logical operators in looking at this can get a little bit confusing sometimes. So let's go ahead and run this. Okay, so there it is. It's not eligible. So we've said that this person has to be or is a student. We set that Boolean to true. But then we said, well, if you're not a student, then you're not eligible. So you have to be very, very careful when you're dealing with logical operators and the way you're writing the actual logic to the functionality of the application that you're creating. Okay, so what happens now if I change this to false? What happens now? What it's saying is they're not a student. So if they are not a student, then in order to accept them, they have to be eligible. So let's run this and you can see that this changes now. And keep in mind, look at the big picture of what we're trying to achieve here. This is somebody in the university administration who's using an application. What they're seeing is checkboxes or drop-down boxes and stuff like that in their application. But in the background, in the code, this is the kind of thing that the software is processing. Okay, so these kinds of little logical operators can get a little bit tricky, but you just have to really dig in, pay attention to what you're doing, and constantly test to make sure you're doing it properly and getting the right output given the right condition. So now let's go in and make this even more complicated. Let's rewrite this line. Okay, so we're going to do this. We're going to say if high grades or a volunteers, okay, but the thing is, if I want to kind of really do a lot more with this, what I'm going to do is I'm going to put this into its own bracket, this own conditional bracket. But then I want to make it even more complicated and then say, and not a student. Okay, so look at this logic here. If they have high grades or they volunteer, and in this case, they don't have high grades, but they do volunteer, and they are not a student already, then what do you think based on this logic is going to be the output? Let's go ahead. I'm going to clean this up, give you a chance to think about it, but what do you think it's going to result in? And there you go. They're eligible. Okay, so really, if you can mix and match with the and, not, and or logical operators and try to really get creative to solve logical problems within your code. But I warn you, this does take a lot of practice and a lot of testing. Okay, you just have to keep at it and you'll get there eventually. What I'd like to do is go back and do a little bit of editing in this and change a little bit of this code a little bit because I want to explain one or two little extra things here. And in this particular condition, we're always trying to get to the evaluation of true. That's actually the goal, is to write lines of code that always evaluate to true. So no matter what, ultimately, these are going to evaluate to true. And just because these are false here, but when you look at the logical condition, in the end, everything always comes back to evaluating to true. Okay? It's like saying, I'm not 18 feet tall. Okay? The question could be, are you 18 feet tall? And I can set that to false. But even though that's false, it's actually a true statement. I am not 18 feet tall. So what happens here is we talked about before where the compiler will go from top to bottom, from line 1 to 2 to 3 and sequentially down. But in this particular case, what it's going to do, it's going to go all the way from left to right. And the first time it bumps into a false statement, that's when it's going to short circuit and it's going to end doing the evaluation. So let's run this and see what happens. Okay, and what you see here is that it is not eligible. Okay, and that's because it came to the very first thing and it realized, okay, the high grade is false. So it didn't matter what came after it. It just found the first thing and it said, okay, go to the next line. And this is it here. What I want to do is just kind of show you something called chaining comparison operators. So I'm going to clean all this up. And in fact, I'm just going to delete everything here. And we're going to say that a grade should be, let's say, a grade of 80 and 100 to get an A. Okay, so what we can do is we can say grade equals, what's a good example? We're going to go with 85. We're going to say grade is equal to 85. And so, of course, I can do this. I can do if grade is greater than or equal to 80 and grade is less than 100. And I'm going to put, don't forget the semicolon in here, or sorry, the colon. Then print out that you get an A. Okay. So let's go ahead and run that off after I save it. And you see that I get a grade of A. But here's the thing, I can do this better in one more different line. So I can do this. I can say if 80 is less than or equal to grade and less than 100, this is how you would have done this in math. Okay, but here's the really good news. I can also do this with code. Okay, so I'm going to highlight this and I'm going to press down my Alt key and my up arrow and I'm going to move it here. And then I'm actually going to modify this a little bit. I'm going to just type in if and then add my colon at the end of this. And I don't need my line 3 anymore because they're the exact same thing. So let's go ahead and change this, let's say to a 90. It doesn't matter. It was still going to work. So I can go ahead, save that, and then run it. And you can see that I still get an A. Let's just change that to 70. And we're probably not going to get any output to the screen whatsoever. And we don't, because we didn't create a message for that. So ultimately, this is what we're referring to as chaining a comparison operator. Okay, in the last case, I had grade multiple times different conditions. In this case, I can just have it in the middle and put my conditions on either side of it and do those comparisons. There are several times within programming that we want to repeat a task several different times, a number of times in a row. And for this, we use something called a for loop. Now, for loops typically will go hand in hand with something called an array, but we're not there yet. We will be, but when we get to the array, this is going to be a little more important to you as a developer. So let's go to Visual Studio Code and look at some examples on how to do a for loop. Let's look at an example where we want to send a message 3 times, at least until it gets received. After that, it doesn't really matter what happens, but just for example's sake, we want to send this message 3 times. So we're going to say print, and we're just going to say, how about this? Hello. Okay. Typically, from your understanding of programming right now, what I would have to do is if I wanted to print this out 3 times to the screen, is I would end up having to copy it 3 times. Okay, but that is unbelievably inefficient code, and it doesn't actually account for logic very well. So this is not the most desirable thing that we would want to do, to try to print out this message 3 times. And if we run this, you're seeing that yes, it does in fact print it out 3 times. Okay, what if, for example, you wanted to put a whole series of hash marks across there? Would you do this a bunch of times? I mean, that's an option you want to do, but suppose you want your user to be able to interact with that and type in, let's say, the area of a box or something like that, or the perimeter of a box, and you'd ask your user, how many feet is one side of the box, right? You're not going to keep sort of repeating this code over and over. And so what we do is we use something called a for loop. And the way this for loop is we do for number in range. And this range is a special library function. And when you type on this thing here, what I can do is actually, you see this description of what you can put in there, but we're going to say 3. Okay, I'm just going to type in the number 3 in there. So let's go ahead and run this code here. But before we do that, in order to see something, we're going to type in a print. Okay, and in here, like we did the last example, we're just going to type in hello. Okay, and now let's go ahead and run this. And you can see that I'm missing something. And it's just like in the other code that we did with the if. I'm actually missing my colon. Sorry, my colon here. Okay, so that's an important thing that you shouldn't leave out. And what's really great here is that when I ran this, and you can see that I've got the problem, but you can kind of get an idea of where the problem is. There's this little arrow right now that is pointing to where the arrow is. So I'm going to go ahead and save that. And look at this. I've got another error here. And why do you suppose I would have that other error? So let's say I hit the delete button and I do this. Now that I have that semicolon there, and then I hit the enter, you can see that the actual, and then I hit enter, put it onto the next line, it went and it was indented 4 spaces. And that's because of the PEP 8. Okay. So I'm going to save that. And then now let's go ahead and clean that and then run it. And now you can see that it prints out 3 times. Okay. Okay, so we're not done with this yet. What is this number right here? What does this mean? And this number, this variable, is actually an integer. Okay, and this is typical of for loops in Python. So what I want to do now is actually, I want to have a look at that. I want to know what that number is. Okay, so I'm going to put that in there within that print statement there. And now I'm going to run this code, and you can see what I'm getting here. I'm getting hello 0, I'm getting hello 1, and hello 2. And remember previously in another video, I talked about our element name. We always start an array element with 0, and then we progress to 1 and 2. And I said just a few minutes ago that for loops almost always involve arrays. In this particular case, we don't have to use an array for this, but we can actually identify the element of an array. And don't worry, there's going to be an entire section devoted just to doing arrays. Okay, so don't worry too much about the arrays. Just understand that when we're dealing with iterating, or we're dealing with arrays, or cycling through something a number of times, we always start with 0 and we progress from there. Okay, let's keep going. Now, having said that they all start at 0, it doesn't mean that I can't go in here and manipulate that a little bit. So let's go ahead and see what happens now that I've done that. And you can see here now that hello 1, hello 2, and hello 3 are now printing to the screen. Okay, and that's a little bit more sort of meaningful or intuitive than saying, well, what does hello 0 mean? At least you know that that is the first time that we cycled through it in this loop. Let's look at a couple other really fun things that we can do here. I'm going to put in a comma, and I'm going to put in a couple of brackets here. And we'll do number again, and we're going to say +1. And outside of that bracket right there, what I'm going to do is multiply, put the multiplication symbol, and then I'm going to add in a string. But it's not text like a word that I want. It's actually just going to be the dot. Okay, and now let's go and have a look and see what this does. This is kind of interesting. And you can see what it's done is it has also cycled through the number of dots, and it's called an increment. There's another way or other techniques that we're going to do incrementing, but what we've done is we've started at 1 and we've grown in size sequentially by the number that we tell it. And let's try this. I don't know what's going to happen. I can guess though. So I'm going to save that, and then let's look at this now. Notice what happened here. We went to 2, and then we added another one, and then we added another one. So it's not as straightforward or easy as you might think it is, okay? But it takes a little bit of practice to get used to this kind of thing. Now we can go in there and sort of clean up this code altogether. And the way we can do that is we can say, all right, inside the argument list of range, you can say start at 1 and go up to a maximum of 4 and just stop just before 4. Okay, and then let's go clean this up, because I'm doing that, I don't need to actually have that +1 in there. And I guess I can take these out and clean this up a little bit, go back to 1, take that out of there. And let's see what happens when I run this code. I'm getting a syntax error. And where do you suppose that error is? It's actually really hard to find, isn't it? But it has something to do with strings, okay? And so my error was actually right in here. I should have taken this out at this point here. Okay, now let's run this again. And notice that time that it wasn't the most obvious error that it was in there. So sometimes your errors are really good. Sometimes your error or your debugging is not so helpful. But that just takes some experience. Okay, and now look, the same exact thing happened. Now what happens if I add yet even a third argument in here? And if you look at this, you can read through all of these notes. There's a little up and down arrow here. This is page 1 of 2 pages. So if I click down, I can get more information about this here. And so you notice here in the range, I've got my initial start, my stop, and then my step. This is the step, or the number of things that you want to increment. So if I go back to here and I type in, I say I want to increment by 2s. Okay, now I'm gonna save that and let's run that. Okay, and now what are we seeing? We're saying go to a maximum of 4, stop shy of that, but increment by 2. So it went from 1 to 3. And now let's change that to 10. And I'll save that and then run it. And you can see here, 1, 3, 5, 7, and 9. It didn't reach all the way to 10. The actual notes for that, tell it to stop one short. Okay, so this is where I want it to stop and back up one. Okay, so that's the kind of stuff you can do with a for loop. It is an incredibly fundamental piece of software programming. This is probably about the most complicated for loop you're probably going to ever see, but you never know. You could come up with something incredibly creative and solve a problem that you need with your logic. Let's just clean it up just slightly. Okay, get rid of this and let's change that to 20 and increment it by 5s. Let's see how this looks now. Okay, and look at what we saw. We started at 1, we went to 6, 11, 16. We couldn't actually make it to 20 because we're incrementing by 5s. So I encourage you to look at this and sort of play around with it and test it and kind of break it and debug it and figure out sort of the best combinations or things that you want to do. Because maybe I don't want it to say hello. Maybe I do want it to be just simply something like this. And I want to change this to 101. Okay. And forget about number. I just want it to print out that. Okay. So let's run that and look at what happened. I got 100 lines of these hash marks. Okay. So this for loop is incredibly useful, and I guarantee you, you're going to be using it all the time. The next thing I want to do is look at something called a for else. Okay, and it looks like this, else, a for else. And it's got several uses, but this is probably best explained with another example. So if I go up to here and I do I type this, successful. And I set this to true. Okay. And now I go back to my for loop, and I'm gonna change that back to just being 3 again. Okay, and I'll leave in my $sign here or my hashtag. And let's just run this. Okay, so all we have is this output of 3 hashtags. I'm gonna clean that up. So now what we can do is I can do this, and if successful, okay, then I want you to print this line here for me, and it's going to be successful. And of course, I cannot type and print at the same time, but I think by now you've already picked up on that. Okay, and after that, I'm going to put this special keyword called break. Okay. And what happens when I have this word break? So I'm going to save that and I'm going to run it. And you can see this right here. It ran it one time. You can see there's one hashtag there, but it printed out this successful. Now, what is really the goal here? What we're saying is we want to print this hashtag for a total of 3 times to our console. But we set this successful to be true. And what we're saying here on line 4 is if successful is true, then just print out successful and then stop. Don't print out or don't go through the for loop 2 more times. Just stop after the first time. So clearly, what's the next way that we can test this out to see if it works? We can do false. Now, what do you think is going to happen if I have false in here? So I'll save that. I'm going to clean this and then I'm going to run it. And as you can see, I've now got 3 printed out hashtags in a row. So just by manipulating this here, this little switch, if you will, this true, false, off, on, 1 or 0, really, just by flicking that little switch, I can have an impact on the rest of the output of this project or this application. So just to draw your attention to the indentation, you can see that there's 4 spaces here, and here, but then the next indentation is going to be another 4 spaces. Okay, so we have to be very diligent with our actual formatting. And thankfully with Pepe, we've taken care of that. We've sort of automated it when we did the installation of that. Okay, so let me set this back to true. Okay, and what happens now if I'm trying to send this message 3 times and for whatever reason either it works or it doesn't work? Okay, so we're going to assume that yeah, I'm sending this message. I'm trying to send it 3 times. And let's run this just to see. Okay, we're at 1 hashtag and we're successful. Okay, good. So what happens though if 3 times we've tried to print out this hashtag and we were unsuccessful? It still didn't do it. So now we're going to want to print out this new message to our user. So let's go back to changing this to false again. Well, what we can do is go and add this else. And with the else, which is typical, is I've got to put my colon in there. And now I'm going to print off a message. And this string is going to say attempted 3 times, but failed. Okay. And before I run this, you tell me what you think it's actually going to output to the screen. So let's go ahead and run that. And what you're getting is the 3 hashtags and then attempted 3 times, but failed. So it actually went through 3 times. It broke out of the loop, but then how did this get here? In contrast to that, let's look at this again as a true. Okay, and I'll save that and let me clean that up and then run it again cleanly. And you can see here, it never actually goes into the else block of code. When this is all set to true, this all becomes valid and it runs it 1 time and it stays inside the top half right above the break. It stays inside there. If it was false, then it would have tried to print it out 3 times. It would not have been successful and it would have put out this message in its place. Okay, so that is the for else block. Before I get to nested loops, I want to go ahead and actually clean up my screen. But nested loops are also extremely important to us. So sometimes there's occasions where you want to get into multi-dimensional arrays. And like I said, we're not there yet, but we're going to be. But you want to have nested for loops. Okay, so the best way to do this is just to show you. So if I say for x in range, and in the range, I'm going to select, let's say 5. Okay, and don't forget the colon at the end. And when I hit the enter, I go to the next line. And this is where I can actually do another for loop. And we're going to use x and y as in like coordinates, right? So for y in range, and we're going to just choose, let's say 3. Okay, and now I am going to put my colon. So you note now that after that, I hit the enter, I go down on line 3 to the next line in the indentation. And so what I'm going to do with this is I'm going to print out the coordinates. And so if we do this, and we've seen this syntax earlier on. Okay, so we're going to do a 4, okay, or sorry, an F with our quotations and then brackets. And inside the brackets, we're also going to do these. So I want to see what X looks like. And I'm going to add a comma and I'm going to do more of these and I'm going to do Y. And so let's have a look and see what this really prints out to. So when I run that, you can see that it is doing coordinates 0, 0, 0, and 1. Okay, and so what it means is it's iterating through each of the coordinates in that range. Okay, and it's stopping. The highest number should be a 4 for the very first one. Okay, because we're saying 5 is the maximum limit, so go to 5 and back up one number before 5. So that's why we've got 4. And then the second thing is the highest number that we should be getting on the y coordinate should be a 2, because it is one less than the maximum range. Okay, so what I'm doing here is I'm printing out and I'm using these brackets, and I'm using these this comma. And remember, this has to do earlier in the lesson we talked about concatenation, but this is sort of the shorthand form of concatenating and putting it all together. So what this is actually doing is it's saying, okay, start here at 0 and continue all the way through this process until you get up to 4. But each time you do it, add another coordinate. Okay, so this is one of those ones I definitely encourage you to pay attention to and also to play around with, because this is going to come back in the future when we're dealing with arrays. Okay, very, very important for you to understand this. I suppose if anything in this entire video that I've done, if I wanted to give you a quiz, it would be on the nested for loops. So to help you try to understand this, I want to put in a little comment. This is referred to as the outer, yeah, I'm tired, loop. Okay, and this one is referred to as the inner loop. Okay, and so this is what you have to try to understand with what is going on. And I want you to think of this in terms of an apartment building. Okay, a high-rise apartment building. You have a first floor, and that first floor is kind of, we'll start that at 0. The first floor is 0, and then you have multiple apartments that are horizontal on that first floor of your building. And then you go up to floor number 1, and again, you've got horizontal apartments. So another way to think about this really comes down to a bunch of columns and rows. Okay, and especially when we're talking about machine learning, it's very important because you're going to get into things like matrix multiplication, where two-dimensional arrays are going to be important. Okay, so this is something that you really, really need to get into your mind. And I guess if you really, really want to think about this, think about it in terms of columns and rows, like an Excel spreadsheet. Or another analogy to think of, it's like an apartment building where you've got floors and you've got individual units inside those floors. And from top to bottom, all of those floors are identical. If you look at those floors in an X-ray or a blueprint, and you would see that each apartment is stacked on top of one another inside a big tall column of apartments. Okay, so whatever analogy you can come up with to make sense of this, please, I really want to emphasize that you need to understand this type of syntax. Let me see if I can try to explain a little bit of what's really going on here. This loop here, the inner loop, is going to actually get executed 3 times before the next outer loop actually starts again. So what happened is, right from the beginning, we start from the top down, and we start the outer for loop. We start that. And that is really identified by element 0 right here. And while we're in the very first loop, we went down to the next loop and we realized, okay, we have to cycle through this 3 full entire times. Okay, so once this was cycled through and that loop became complete, we then went back up to this loop again and we repeated the cycle. And so that is how this is really functioning. Okay, so we do the first one time only, and then we cycle through here until this one is completed. And then once this is completed, we go back to the top and we do another cycle. And then this one cycles through 3 more times, just like it did previously. And when it's completed, we go back out to the outer loop and we just continuously repeat that looping cycle. Now, could you imagine what your code would look like if you tried to do this with a whole bunch of copy and paste lines of code on there? It would be a nightmare. So this is why we use loops. Okay, could you imagine trying to code all of this into some sort of logic without a loop? It would be terrible. So this is what's really going on. And again, I can't emphasize how important this is enough. Okay, let's move on. Remember previously when we were talking about types, and if I want to look at, let's say, for example, the type of what is 5, I could do this. Remember this sort of idea of casting. And the way I do this, when I print this off, what it's going to do is it's actually going to tell me the type. And it's showing that this class, is an integer type. So the other thing that I can do is actually look at something in a little bit more detail, because as I said really early on in one of the other videos that about variables, that variables have a data type, right? And they were primitive data types. But there's also this other thing called a complex data type. So if I want to look at an example of a complex data type, I can just do print, and in here I can do type, and in here I can actually type range. Range is now my data type. Okay, and inside here, if I type in my 5, and now I can go ahead and run this, you can see that its data type is range, and that is considered a complex data type. And so we will get much more into complex data types in the future. And so what's interesting about this range is that it is iterable. And what that looks like is iterable. Okay, so it is iterable. And so what we can do is stuff like this: for x in range, and type in 5, and let's not forget our colon. Okay, this is why we can do this, is because we can iterate over range. And if you're wondering what I mean by the word iterable, think of the game maybe you played as a child. It was called Leapfrog, where you jumped over your friend's back in a sequence, and you constantly jumped over each other. It's the same sort of way. You're iterating, you're increasing as you go through an entire cycle, and you're increasing, and sometimes you're decreasing in size as well. And so what this means is that every time I iterate over this range, it means that X is going to increase in size. It's going to get a new value every time I go through an entire for loop cycle. It just continues to increment by 1 in this particular scenario. So range is not the only thing that is iterable. There are other things that you can iterate through, and you can actually iterate through a string. Okay, and if I put in my own name there, I can actually iterate through the characters inside my name. And so before I run this, let's clean this up a little bit. Okay, and now I want to do a print and put in the X, because X is what I'm going to iterate over. Okay, save that, clean this up, and now I'm going to run it. And you can see that the name Tom does print out vertically on each new line. So I've iterated over the characters inside that string. Now another example, and please be aware of this one. Don't let this one just get dumped out of your memory. Okay, we can do a list. Okay, it looks like an array if you've been in other programming languages, but this is a list. And the way we do this one is with square brackets. Okay, and we can say 1, comma, 2, comma, 3, comma, 4. Okay, and we can iterate over this list. Okay, really, really important that you understand lists. So if I type the save and do this, now you can see that I'm iterating over this. Now, what is important to understand is in this particular case, I'm playing leapfrog with it. I'm going over top of it. I'm not actually incrementing it. I'm not making the numbers bigger. Okay, I'm not adding anything to the original size of X. All I'm doing is I'm saying output on this cycle each new number. And every time you do a new cycle, go to the next one, iterate to the next number in the list. Before I move on to the next type of a loop, I just want to stress that we are going to come back to this. This is something that will become very, very important to us in the very future, because especially in machine learning, if you want to be writing your Python code for machine learning, then you're going to need lists and you're going to have to understand how for loops work. Okay, so I guarantee we're going to come back to this. Okay, so please make sure that you fully understand this specific topic. The next thing I want to talk about is very important. It's actually called a while loop. And the while loop is when we actually do a loop as long as a condition is true. And of course, this is one of those things where it's best explained in Visual Studio and I show you a demonstration. But just understand that there's kind of a saying that you can do is that while something is true, then continue to loop through it. Okay, and let's go look at that example. So if we say number is equal to 10, and then we say while number is greater than 0, then what? Okay, and this evaluates to a very true statement. So as long as number is in fact greater than 0, we're in a state of being true. This is absolutely true. So let's print this out and see what this print is. What's this going to do for us? So we're going to say number. Okay, but then let's say we want to do another operation here, and I'm going to say number, and I want number to then be number divided. Now remember what I said about division. It's 2 slashes divided by 2. Okay, or you can do it another way, and I'm going to show you this other way, and you can do it this way. You can say number is actually divide. That's the shorthand for this to be true. So this one will work. This one is just as valid as this one. So they're somewhat interchangeable, okay? But for me, I actually like to do it this way. This is what I prefer because this is easier for me to understand the logic of what somebody is doing. So if I run this program, you can see what we're getting here. Okay, started at 10, 5, 2, and 1. And let's walk through what this really means. So we're not iterating. What we're doing is we are evaluating over a condition. And while that condition is true, then we're completing a task. We're saying print out the number and then perform this operation, assign it to number, and then go back to here and then pick up the new number because again, we're in a loop. Grab the new number and then perform the same operation again. So we start off at 10. We go to here and we say, hey, is number greater than 0? Yes, that's true. So print out the number 10. But after you've printed it, then I want you to take 10, divide it by 2, which is going to give us is going to be 5. Assign 5 over to this number, and then go back to line 2 and reevaluate the condition. Is 5 greater than 1 or 0? Is 5 greater than 0? Yes, it is. And repeat the loop until you get down to this situation where you can't divide by 2 anymore. And when 1, you can't divide 2 or 1 by 2. You can do this infinitely in a manner of speaking, but ultimately, when you have now manipulated 1 to the point where it's no longer greater than 0, then the loop has to stop. So this is really how we are terminating the while loop. It's when the condition now gets converted to being actually false. It's no longer true that number is greater than 0. So therefore, it has to be changed automatically to false, and it terminates the loop. That's how we break out of that loop. Did we ever cover a lot of different topics? This is actually an incredible amount of things to go over. And if you stuck with this video to the very end, you should be congratulated, because this is a lot of content to try to digest. Now, try to manage your own self-expectations, and just take my word for the fact that this is a lot of stuff that you would have had to digest in this programming. And it's going to take you some time to get really comfortable with this. It's going to take a lot of practice. And my advice to you is to go out and try to look at some of your day-to-day decisions of things that you've made and come up with little examples on your own. And the second thing I would say to you is, if you can, try to explain all of these different things to a friend. I know that sounds a little bit bizarre for something that maybe you don't even know yourself, but if you can try to explain this to somebody else, you might actually surprise yourself with what you do know, but it will reveal to you the things that you don't. Write those down, go back and practice, and then try to explain it again. Now, you don't have to find a friend or anything like that, but just try to do it yourself. And what I'm talking about is actually something called the Feynman technique. And Richard Feynman is a Nobel Prize winning scientist who was actually one of the greatest minds of his generation. But one thing he was really, really known well for was taking something that was extremely complex and making it very easy for people to understand. And this is the way he taught. He asked students that were having difficulty, explain it in the simplest terms that you can. Until you can't explain it anymore, go back, research the piece you're stuck on, and then re-explain it. Okay, so that's my little tip for you today. But if you've stuck with this video this long, you really should be congratulated. It is a lot of content, and it is something that is going to take a lot of practice. Now remember, you're not going to be able to cram this stuff. It's like trying to go to the gym and pull an all-nighter in the gym and expecting the next day that you're going to be as big as Arnold Schwarzenegger. Okay, it's just not realistic. You need time with this material and a lot of practice. So again, thanks for watching, and I will see you soon in the next video.